Well, welcome back everyone. Episode 21. This is the follow-up to the trilogy that we had for episode 20 with A, B, and C. This is taking us into the AC distribution smoke test. Oh my god, what a nightmare. There were a lot of problems with this. I had issues with my own distribution. I had issues with the MK-3. I had issues with anything and everything you could possibly imagine. So based on that, let's get through this. This is a long one, and it needs to be a long one because there's a lot of lessons learned on this. So let's see what happened. Let's get after it. Well, welcome back everyone. It is Sunday, June the 1st. It is early afternoon. We finally got through the long saga from the previous episode 20 with parts A, B, and C, and now we're working on episode 21. In this particular instance, I'm going to try to close out terminating all of the AC outlets so that I can actually program and get those inverters online and test some circuits and see what kind of AC power I can get. I did do a few things yesterday, but I couldn't do a lot because I had some things that I had to take care of. But one of the things that I did was I got my temperature sensors installed on my 12-volt battery, so that's in place. That's all programmed and configured, and they're all working. I'll show you that in a second. One of the other things that I did was I brought up the remote for the DC to DC chargers up to the front dash. I did that so that if I'm driving and I'm starting to see some issues with my alternator, my charging or whatever, I can kill that down and do one or the other or whatever the case may be. But we'll take a walk and I'll show you that switch as well and show you what that looks like. Maybe if I have time, we can get the bus started and show you how it works. But that's where we're at right now. One of the things that I'm getting ready to do is start taking you through the split circuit receptacle wiring. I got one in. I'll show you in a minute, but I had to I'm having to undo it. I bought a bunch of shallow boxes and they're not working, so provide a few tips and tricks on that and some safety stuff as well. But first let's take a walk and I'll show you those temperature sensors and those switches and one other thing that I did. Alright, if you look in there, you'll see that black spot. That's Gorilla Tape, and the sensor is underneath it, and I've got it tied across the seam of my 1-2, 2-3, and 3-4 batteries, and up there on the sensor, they're registering accordingly as well. Got them coming up through that hole that I put right there, and then they plug into my Servo GX. A little light on the subject. Plug into my Servo GX. I can get it right down there. Actually up there towards the top of the Servo GX. Got that blank block and then all those wires going into that other one. So there's my sensors. So if I bring it to the top, go to the Servo GX, bear with me, come up here and hit this. There's the levels, if you can see it. Let me try to well, this glare. There you can see it. So I got my battery compartment temp. I've got battery 1-2, battery 2-3, and battery 3-4. Then they're all sitting pretty much at about the same level. A little bit of differences, but not much. The biggest thing is the compartment temp at 81. I'm thinking that the alarm relay might kick off while we're doing this if it climbs up too much. But I got the max air fans on circulating air, so that may help keep it cool. But as you can see on the Redodo monitor with both max air fans on, and all the lights that I do have on right now, I'm pulling about 3.7 amps. So that's where we're at right now. So that's one of the things. So here's the other thing, and I need to clean it up, but this wire right here runs all the way up to the front dash on the 12 volt side and goes to a switch up there that allows me to provide remote on off for the DC to DC charger back here. If I put a little light on the subject and come over to the 24 volt side, you can see right here I have exactly the same thing. So now let's take a walk, and I'll show you the switches up front. Alright, so if you see this switch panel right here, this one goes to the 12 volt side, this one goes to the 24 volt side. And when I'm running down the road, if I want both of them charging, I just close both of them so that they would be on, and both DC to DC chargers would be charging off of the alternator on the bus. If I want to kill either one of them, I just turn one or the other off, or I can even turn both of them off, and it's a remote switch that shuts down the DC to DC chargers. Just did that for a little extra control, visibility, and safety, so that I didn't have to worry too much about that. But that's what I did with that. Alright, so we'll take a quick walk outside so I can show you one more thing I've done, and then we'll get back into these circuits. Alright, if you see this handy dandy little knob right here, this is because the little flat plastic lever that they had in there that you would run through the slot and then turn it to lock the panel in place, it broke on me. So what I did was I went and drilled out the catch plate in the back, put a rib nut in it, and went to the lumberyard this morning and got this, and screwed that into the rib nut to hold it down. Now it's all nice and secure. It's tight, it's not going anywhere, so that took care of that problem as well. So with that, let's go back inside and start looking at some receptacle work. Alright, yesterday evening, in addition to doing those temperature sensors and taking care of the remote switches for the DC to DC chargers, one of the other things that I did was install my microwave receptacle. Well, as you can see, that is not very nice, and I don't like it, and part of the reason is because of the wiring that's in there, and I'm going to fix that, and I'm going to walk you through that, because I don't like the way that looks, and I don't like the way that works out. Just to give you an idea, so I bought shallow boxes because of limited space. I thought they would work well, but with the double wiring in there. So here's the shallow boxes. That's what's installed right now. That's actually what is on the ballast plug for my water filter, but there's only one wire going in. And one of the things that I did with that as well is I used the stranded wire directly to the screws. I didn't like the way that it looked. I might go back and fix that and change that box out as well. And so as a result, I put termination ends on the ends of those wires to terminate them to the plugs, and that's creating part of the problem. But this is what I got. Same size, and it's an old work type electrical outlet where you just put a hole in the wall and screw this screw down, and it holds it together. I'm not going to take advantage of that because I don't necessarily need to, but I can secure it into the wall with these screws right here, which is what I intend to do. But anyway, that's where I'm at, and that's why I've got to redo that one. So what I'm going to do is I'm going to take this down and get that out, break it all down, and then I'll bring you back and show you how we put it back together. Alright everyone, there it is. So I got the new box in. I had a little bit of problem with it because they are not exactly the same size as the other ones, so I had to do some manipulation. The old work levers that were on the back actually worked really well, so that tightened this thing down, and I was able to get one screw in this corner back here. Some things that I want to show you. So I've got both grounds tied to the ground of the receptacle. Notice that the ground prong is on the top side. I believe that's a code requirement. At any rate, it's safety if nothing else, because if the plug gets dislodged and something falls down there, it's going to hit the ground lug and bounce off, hopefully before it hits the line side of the plug. One of the other things that I also like to do, and I don't know if it's code or not, but I also like, if I'm doing them horizontally like this, I like to make sure that I put the line side up. You'll notice there's silver screws there, which represents the line side. One of the other things that, from my experience and knowledge, and I've never seen anything different, is that the line, not the line side, I'm sorry guys, the neutral side of the receptacle, the neutral side of the receptacle is always on the same side as the ground. So I put the neutral side up if I'm doing them horizontally. Same reason, if the plug comes dislodged and something falls across, neutral and ground are bonded at the source anyway, so it's just a little bit of extra safety. And so horizontal, I put the line side up, vertical, I put the ground side up, and got them all wired in. So just so you're aware, this side of the plug, which is the top side, is the inverter power. This side is the shore power, and that is going to be the same convention on every one of the plugs that I put in, so that I don't have to mark them, I don't have to remember them. The wires are marked very clearly, and for several feet. Excuse me. I probably will put a label on the cover, just so it's clear what's inverter and what's shore. But there it is. So now I'm going to feed the wires in there and get that mounted to the box and put the cover plate on. Not always easy, that's for sure. Oh, come on. And that is a much better installation than what I had before. No gaps, no seams, everything is nice. They seem to be a little bit of off level, but one of the other things that I did, I put this hole up here so I could feed the plug out from behind the microwave. There was not enough room for me to put the plug in the back so that you pull the microwave out and then unplug it. So I put this hole up here. It comes through, and you just plug it in. One of the other things that I like about this, as opposed to having it behind the microwave, if I want to shift from inverter to shore, I just open the cabinet up and move the plug. And I'm going to do that with all of the different plugs that I have. So, all right, so there it is. There's one. I've got 1, 2, 3 more that I need to do right away. The next thing that I want to do is run to the back and do something a little different. And that is wire in my 220 plug that I have for the back of the bus, and I'll walk you through that. Let me go get that set up, and I'll be right back. All right, I'm back. I got this thing squared away and set up. Let me get it so you can see it. So as you can see right here, I've got my ground connection right there, my L2 connection right there. Flip it over, I've got my neutral and my L1 over here. You have to pay attention with these things because you're wiring according to the location of the plug parts, and not like the other ones, which are fairly standard. But it comes well documented, it's well labeled. So basically I put this back here for a very specific reason. If you look right here, let me drop this down here so you can see it a little better. But I've got this splitter right here, and this is a NEMA 14 NEMA L14 30P for a plug. It's going to plug into this right here if I need it, and then I'll have 3 different individual single phase outlets that'll run and provide power should I need that on the outside of the back. What I really got this for was for my generator, but it's going to prove a useful purpose here as well, which is why I put this plug. It took me a little bit longer than I expected, because if you look up there in the top where the wire's coming down, I had to drill a hole there, put a grommet in, and then fed the wires down, brought them down here, and have them coming in right here. Right now it's just going to be sitting here. It's not permanent mounted because I need to frame all of this up. But one of the things that I want to do is go ahead and close this up and show you what that's going to look like. So let's try to knock that out real quick and see if we can get this one done. Alright, so that's in. It's going to be like somewhere right here on the, well, let me fix the camera so you can see that, but it's going to be mounted somewhere along this area right here when it's all said and done. I've got enough wire that I can do that. The wiring is actually going to run along here and then come down into the plug like that, but for right now it's just temporary. Next thing I want to do is go ahead, hopefully this is the right one and it fits, but get that cover plate on, provide some security and safety to that plug, and she's done. So when it's all said and done, it'll be right here on the finish wall, not in the line of the door, but it'll be on the finish wall right here. For the sake of demonstration, if I come up here, line this thing up, put it in there, and turn, and it's locked in place. So there you have it, and then I'll have 3 different plugs that I can run off the back side of this. Alright, that covers that. So I've got several other circuits that I need to run to terminate this so I can configure the inverters. I'm going to try to get them all done today so I can get the inverters configured, but we'll see if I can get there. And I'll be back soon. Well, welcome back everyone. I got her done. It's a long, tedious process, but I've got every single circuit feed coming out of my panels terminated. At least everything I can find. I hope I haven't missed anything, but I'll find out. So I've got 2 right here. These are for right behind the cab. I've got special, what am I trying to say? Special intent for these. I'll get to that later. You'll see that, but I've got these. Both of them have inverter and shore power inputs. So they are wired in the exact same way. So inverter on this side, inverter on this side, shore on this side, shore on this side. So with that, let's walk back and look at the next thing I've got going on. So right here is the refrigerator input. I've got inverter on top, shore power on the bottom. It is plugged in. So as soon as I put power, my refrigerator is going to come up. Got that done. I had to cut the hole in the cabinet. I was kind of limited on one of the wires, which I don't like, but I'm not going back into my AC panel to lengthen the wire, so I made it work. But anyway, so 2 circuits up there. I've got my refrigerator right here. We already discussed the microwave, which is right there. I did that earlier, so it's got shore and inverter power on it. My ballast for my water filter is only inverter, so it doesn't have that, and it's not a split circuit. Let's walk a little bit further back. Everything's a mess, I'm sorry, but I've been working and trying to get everything done. So what I want to share with you right here, this is the bedroom area. So I've got a plug right here. Again, this one is inverter on top, shore on bottom. One of the things that I do want to share with you is that the shore comes up right here, crosses over, and comes down into this one. Excuse me, I know I'm making a mess with this, but so this particular plug right here is shore only. This particular plug right here is shore and inverter, so inverter on top, shore on the bottom. This plug right here is inverter only. And there's a specific reason for that you'll see in the future, but I wanted to point that out. So every single circuit feed that I have in this bus is now terminated. There's that 220 plug that we talked about earlier. I do want to go back up to the front and point out one more thing that I want to let you know that I did. So this particular circuit right here is a feed circuit that runs, excuse me, it runs off of my ground fault circuit breaker. It only has inverter power in it. I'm not trying to do ground fault with the dual power input on the switch. So I wanted to get that terminated so I could test my ground fault and make sure that's all working as well. So at this particular point in time, I have every single circuit feed. Now that doesn't mean, like for instance, this ground fault, there's going to be several other plugs on this. But every single circuit feed that I can find that I have connected to my AC panels are terminated with a receptacle. It is approaching 10 o'clock. I'm going to call it a night. I'm going to shut it down. And hopefully tomorrow I can get the inverters configured. Get my laptop out here. Get that MK-3 set up. I've got everything downloaded, so we should be able to walk through that pretty quick and get all those inverters up and running and actually test some of these circuits. Make sure they all work. So with that, I'm going to shut it down for tonight. I appreciate you being with me, and in the blink of an eye, we'll be back, but it'll be tomorrow. Well, welcome back, everyone. It's Monday evening. It's late. It's approaching 8 o'clock. Unfortunately, I wound up working late, and I had some company come over, and I couldn't get to this as soon as I wanted to, but I did want to run through the whole process of trying to get my inverters configured. First thing I'm going to do is run through the VE bus quick configure to get them set up, and then we'll go and take a look at see what's available if we approach the process from the VE bus system configurator. I'm hoping you can see my screen. I've tried to do as much as I can to zoom it in, but I've got quick configure right here. I've got system configurator. I've got VE Flash right there, and I've got Victron Connect. I've looked at VE Flash. I don't know that that's going to be very useful unless you download files and then identify them for upload. And then Victron Connect. The only thing that I've done at this point, just so you're aware, is that I have created an account with the VRM portal. I do have my 24 volt Servo GX registered with the VRM portal, and I'll show you that in a minute. That's about it. We're going to learn something together. I've never done this before. I hope this works. Both of my inverters are off, but 24 volt power on this side is on. Everything is up and running. I can see everything so far at this particular point in time. So at this point, what I'm going to do is I've already opened up the quick configure. As you can see here, VE bus quick configure. And so we're going to run through this and see how this works. And hopefully everything comes out all right. And once everything is configured and set up, we'll run through and do some testing of electrical circuits and see if we actually do have power. And the way that I have the distribution set up is I'll be able to check circuits on different branches, so I'll be able to see power, single phase power on each branch. by running through everything. And I won't be able to do any split phase actual power checking until I can get my mini splits ready to power up. But until then, we will see what's going on. So at this point, we're going to click next, which is right here. And we are going to set up a VE bus system because it's never been set up before. I'm assuming that's correct. We're all learning something together, guys. And we are going to do a split phase 180, which is what normal house power is. And I don't have any of these devices, so I don't have to worry about this. There's no inverter control. There's no multi-control. There's no V-bus multi-control or digital multi-control. So I don't have any of those, so they don't need to be connected. The only thing that I have is my Servo GX, and it is connected. So let's go to next. I'm assuming COM3 is correct. I'm going to put it on auto detect just in case. So we'll go to next. So all devices are off. So we'll go to next. And now it's telling me to switch on the inverter that is going to be L1. So I am going to reach back here. I don't know if it's on the camera, I can't see, but I'm going to reach back here and I am going to switch that on. And it's telling me it can't find my MK-3. Let me turn that off. So I need to turn it off. Press OK. So I've got my MK-3 and it is plugged in, which is right here. And the USB-C comes in on the other side and connects over here, which is right there. I don't know if you can see that on the camera or not. So let's go to COM3. Can't open COM3. COM4. Can't open COM4. Alright, what am I doing wrong here, guys? Always fun, always fun. And like I said, I was trying to do this live and on the air, so alright, I don't know what to do at this particular point in time. The only thing that I can figure is that I am not using a Victron cable for the connection from the inverter to the MK4, so I'm going to try to swap that out and see if that helps, and we'll be right back. Alright guys, I'm back. We're going to see what we can do to try to get through this. I do have to tell you that I am not happy. I am not impressed. I'm going to run through a few things that I've had to do since the last video. I left the last video in to show you that things don't always go as planned, and they create a lot of problems for me. That video was recorded on Monday. It is now Thursday. I've spent the entire week troubleshooting and trying to figure out what's going on and getting everything configured. I've made a crap ton of progress. I'm really happy with that. A lot of my own issues, a lot of Victron issues. I'm not really happy with some of the equipment that I've had to deal with, but we're going to run through that, and I am going to show you what I wound up doing. So just so you're aware, the Multiplus 2 inverters on the 24 volt DC side are actually configured for split phase. They are actually working. I have actually tested every circuit that is on them. They function correctly. The only circuits that I have not tested is the one that goes to my mini split. I am not putting power on my mini split because I don't have any lines connected or anything like that, so that is not going to happen in the immediate future. One of the things that I do want to try to share with you is to run through that process. It is challenging. One of the things that I figured out over the past couple of days is that I have the MK-3, which is a USB C to V bus adapter. Well, the challenge in the video that you just saw was that I was not able to get that to connect to my computer or to the inverters. Troubleshooting that, working with that, validating that drivers were installed. I went through a whole laundry list of things that I needed to do to try to verify and validate why that was the problem. I figured out quite by accident that the challenge with that MK-3 is the piss poor RJ45 connector they have on the end of it. It is very sloppy. It does not make good connections. And my years of experience in working in electronics and stuff is reseating cables and things like that. And in the process of trying to get this stuff to connect and stuff, I kept playing with cables, and I disconnected and reconnected the RJ45 connection on the MK-3, and lo and behold, all of a sudden everything connected and everything worked, and I was able to get it configured. I still have that problem, and I am going to try to show you that everything is configured and stuff, but we'll see if it actually connects or not. I cannot guarantee that, and if it doesn't, then I'll have to play the cable reset game and keep doing that until it connects. But I am not very happy with that. That is a very piss poor design. There's a lot of slop in those connections that should not be there for an RJ45 connection. Those should be solid, those should be tight, there should be no movement, and they are all over the place. So not very happy with that, and I lost a lot of time just troubleshooting that particular component of the connections between my laptop and my inverters. Based on the challenges that you saw in the last video, one of the things that I thought was that maybe I had some USB problems with my laptop. So I actually ordered a different MK-3 that had a USB-A connection instead of a USB-C connection. And I have to tell you that the USB-A does work much better. And so what I have done is I have tried to isolate the USB-C connector to my 24 volt side and use the USB-A for the 12 volt side. At this particular point in time, other than having to reseat cables, it seems to be working fine. So what I want to do is I want to try to show you how this works. There's a lot of videos out there about using the VE config and all of that kind of stuff. It's all the same process. I've got everything configured. I've saved several different configuration files so that I can just quickly migrate from one to the other based on what I'm connected to and where I'm at. But with that said, let's go ahead and I've got my USB-C cable connected to the Mark III, and what I'm going to try to do is go to the VE bus quick configure, which is right there. Double click that and launch it. You can see the screen that pops up next. Check for updates. I'm going to modify an existing system because it's already set up. I want to go to COM3 because that is my USB-C connection. And all devices are on, so I'm good there. And we are going through and seeing if it will detect my Mark III. and it looks like it's not going to do it. So with that, I'm going to do, while we're filming this, I'm going to do a quick connect and disconnect and reconnect. See if it shows up. Obviously not. Move the cable around. Connect, reconnect. Connect and reconnect the USB-C. And this is the challenge that I face, guys. I've been fighting this all week. Created the issue where I had to buy another MK-3, and I didn't really need to. It was just poor design on the part of the MK-3. But I obviously, as you can see in the video, I cannot get the MK-3 right now to register. I will tell you, 10 minutes ago, I had that. It did not have that problem. So we'll continue to fight it. I just want to share this because this is something you need to be aware of. If you're using this, you may or may not run into this. Don't know, but just reset the cable again, still no luck. This is what I've been fighting all week. This is unreal. This should not be happening. All of this should be plug and play. As soon as it times out, since the USB-C is the only thing that I have connected to the computer, we're going to go to auto detect and see if that works better. In this particular point in time, I specifically went to the COM port. Now we're going to try auto detect. I just got to wait for it to time out. I've watched a lot of videos on this, and for whatever reason I haven't seen anyone else have this problem, but for whatever reason I am, and it is extremely frustrating and has cost me so much time. One of the other things that I do want to share with you is that if you're using a Servo GX and you're trying to use this software, you must, absolutely must disconnect the Servo GX from the VE bus, or you will not be able to do anything. I missed that point, and the Servo GX or the inverters or the software or the incompatibility or whatever the case may be, I could not use my computer. It took over my computer, and my mouse and everything was going all over. It was clicking all kind of stuff. It was doing all kind of crazy things. So you must disconnect the Servo GX from your from the VE bus, or this is going to go crazy. And I would give you a demonstration, but I really don't want to see that happen, and all the stuff that happened on my computer. It goes crazy. So obviously it aired out on the connections, so I'm going to go ahead and kill that. At this point I am going to go to auto detect. and click next. Everything is on because we're modifying existing. And we're going to click next. And in this case, it found it. Alright, so what you can see right now, and we are in fact looking at the 24 volt split phase distribution system. I have both my phase 1 L1 and phase L2 180 degree out of phase inverter set up. It's reading both of them. That is a good thing. That's exactly what it should see. And everything is set up correctly. One of the things that I do want to show you is run through some of the settings and things that I did do. And now it says I need to right click and go to VE configure. Here we go again. Alright, it found the MK-3, so it is actually loading everything. This is what it does every time. It goes through and downloads supported functions. And then it goes through reading a numerous set of blocks of information in the Victron inverters. It downloads that into the computer, and once that's completed, then it actually opens up a settings page where you can run through and validate the settings. And I do not have any assistance, so that is a normal indication. I have not investigated that. But anyway, as you can see right now, so it has populated everything. I'm running at 60 hertz. I've got 120 volts on one inverter and 120 volts on the other inverter. Or actually, it's telling me my total voltage is 120 volts. Right now I'm pulling 0.2 amps on the system because I don't have anything on. And my volts DC is at 26.5. So that's where I'm currently sitting as far as the actual input. I can actually open this up, and you can see it provides a little more detail and provides more information. One of the things that I'm noticing on this, which is interesting, well, it says we're not in phase, but that's what it's supposed to be. My DC input is 26.5. I'm pulling about 3 amps. So all of this looks fairly normal, I would assume anyway. So I am no expert on this. I'm still learning. We'll figure it out. But anyway, so if you can see on the screen right now, there's a whole bunch of different tabs on this screen. So the general screen shows that I'm at 60 hertz. Right now I have my AC input current limit at 10 amps, and that's just where I set it right now. I don't have any AC inputs from shore power, so it really doesn't matter. I'm going to set up different configurations for whether I'm connected to 50 amp shore, or my generator, or just grid power with no input, whatever the case may be. I'm going to set that up because I have to control my ground relay and all those other things. So those will all be set up. I do have some saved, but it's just playing around and not really final. So if we go to the grid, I'm not doing grid connections, so that doesn't matter. Going to my inverter, the output is 120. You can see my ground relay is on, and I've set my voltages based on my batteries. I did have to make some changes to this, but not a lot. I think the only thing that I did have to change was my low voltage shutdown. Everything else was normal. Then I go to my charger. One of the things that I did have to do was change this to lithium iron phosphate batteries. Went through a couple of steps to do that, and then made sure that the voltage levels that are down here matched the voltage levels and everything that are associated with my batteries, and they did. So we're good there. One of the only things that I see that I may change is the maximum input charge current from my batteries is 100 amps. So I may change that 70 to 100. However, I also have MPPT inputs and DC to DC inputs. I don't know how those interact, but I'm going to have to look at that and figure out what the right solution is for the max input current. And then if I go to virtual switch, I do not know what that is. I do not have one in place. I have disabled that completely. Do not use virtual switch. I'm going to figure that out though. It might be beneficial, but at this point in time I've got it disabled. I do not have any assistance. There is quite a bit of stuff that you can do to create those. I don't know anything about that. I'm not going to play with it right now because I just want to get this thing working. And then you go to the advanced, and it's just limiting the internal charger to prioritize other energy. What that does is that basically limits the charger capabilities. It limits the charger capabilities so that it prioritizes running loads as opposed to charging batteries. So I'm going to have to investigate that as well. But anyway, so that is everything that I did, and I went through to get the 24 volt side up. It is working. It is operational. I've tested everything. At this point in time, there's a few things that I can show you just to make sure that you know that everything is working. And so we're going to step away from the computer, and I'm going to show you that. Alright, so if you remember in a previous conversation, I put this 220 volt AC outlet here in the back, and the pigtail that I have that plugs into it has lighted circuits, and as you can see, every single one of those are lighted up. So I energized that circuit, and everything is working, everything is fine. I am getting power out of my inverters. I am getting split phase power because this is a split phase receptacle that actually takes those split phase inputs and divides them out and gives me 3 single phase outputs out of the pigtail. So just to show you, the inverters are working. I do have an output, and it is all in place. I have tested all the circuits with loads. They all work. So let's go back. Alright, so the next thing that we need to talk about is the 12 volt distribution side. Guys, this was a total fail on my part. There were a lot of problems that I had with this side of the AC distribution. As you can see, everything is opened up. One of the first things that I do want to point out is that in all of my troubleshooting over the past 3 days, I figured out that I completely, totally, unequivocally screwed up all of the inputs on my inverter. So if we come down here and look, and I'll try to put a little light on it so it makes it a little easier to see, but So you see the 3 green blocks there, right? So the first one is AC1 out, the second one is AC2 out, the third one is AC in. If you will notice, I don't have anything connected to that. That's part of my troubleshooting. Those wires are actually right there. I disconnected that to isolate and try to figure out what was going on. That was not the problem. And anyway, just so you're aware, every single one of those connections was incorrect. Every single one of them. I had my AC in connected to my AC1 out. I had my AC1 out connected to my AC2 out, and I had my AC2 out connected to my AC in. I am surprised that I did not blow this stuff up. Thankfully, there is a lot of fault tolerance in this stuff, and I was able to very quickly realize there was something wrong and shut it down. It was unreal. Major mistake on my part, major attention to detail issue. I don't know how I screwed that up other than just losing track of what wire was what. But I got it all fixed. Everything was working now. One of the challenges that I had, and I've had to completely revamp my entire AC distribution panel for the 12-volt side because I screwed a lot of other things up as well. So as you can see, all of my primary inverter outputs is one here, one here, one here, one here, one here, one here. Well, they alternate like that for a reason. If you notice in the previous video, I had like kitchen plugs and then kitchen plug shore directly across from it. Guys, that didn't work. The way that this thing works is this and this are on the same part of the bus. This and this are on the same part of the bus. This and this is on the same part of the bus, and they alternate. And in the process of trying to troubleshoot why I wasn't getting power to specific circuits and stuff is how I figured that out, and I completely rearranged all my circuit breakers. One of the other challenges that I had was that the device that I used to check the circuits on my 24-volt DC side worked great, didn't have any problem, was able to verify, validate, and substantiate that every circuit worked. Brought it over to the 12-volt side, plugged it in, kicked on the breaker. The DC current on my system immediately surged to over 100 amps. I had a very loud hum off of my inverter, and I immediately shut it down. I'm like, I have no idea what's going on. So for the past several days, I have been trying to troubleshoot that. One of the things that I thought was the ground fault breaker that I originally had from my kitchen plugs by my sink might be defective, so I removed that and put a just standard plug in for breaker in for right now. That wasn't it. Then I decided to figure out, okay, let's try something different. So I went into my house and I pulled out every lamp that I could find, and I put an LED lamp in every lamp that I could, LED bulb in every lamp that I had that didn't have one. And I brought them down here and I plugged them into each one of those circuits. And what I found is that if I did that, everything worked. As a matter of fact, right now I have my fridge plugged in to my inverter and it works. That was very stressful for me because I thought that my inverter was DOA. I bought it back in December and I was sure that if it was DOA, there was no way I was going to be able to replace it, and I was just going to have to buy another one. So, but at this point, everything is working. One of the things that I do want to show you based on this conversation is that if I go over here, so this is my, I don't have anything plugged into this one, so this is my fridge. If I turn this one on, oh no, it's already on, I'm sorry, this is on. Actually, if you look up there, you can see that light on. That's a circuit that I have up there. This is a circuit that I have back here. And if we go up here to my fridge, I think the compressor on my fridge just kicked on. It's nice and cold in there. You can see I've got lights in my fridge. My fridge is on. All of my Max Air fans are on as well. I've got a circuit up here that is also on. One of the other things that I do want to show you that I did as a test, I used that particular receptacle right there. I started with my jigsaw, worked fine. Then I went to my die grinder, worked fine. Then I went to my, I don't know what you call it, the freaking sander thing, worked fine. One of the things that I can tell you is when I plugged that in and pulled the trigger, the DC current draw based on that being connected to my inverters jumped from about, I want to say jump from about 15 amps to close to 80 just with that one device connected. But the point is that everything worked, nothing hummed, everything performed. And the device that I used that created my problem was that right there. I don't know what happened. I used that to check every 24 volt DC AC distribution circuit and it worked fine. Brought it over to the 12 volt side. It shut everything down. I have no clue. So all I know is that is not getting plugged into my AC distribution in my bus. I'm going to get a battery powered whatever I need, but that is not happening. So at this particular point in time, what started out as a total fail on my AC distribution has been recovered. Everything is working. The only thing that I need to do at this point is reconnect this wire down here, which is the AC in from the other side, which provides me my shore power input to this side. And then I will be able to test and validate all my shore power circuits out of this panel. One of the troubleshooting steps that I used, thinking that there may be a grounding neutral issue or whatever, was that because I had these two connected together, there was a neutral problem, grounding problem between the two panels. So I completely disconnected the input from the other side for the AC in to isolate that. That wasn't it. So I'm going to connect that back up, and hopefully what will happen is that when I trip the breaker on this side that provides the AC output from this particular setup over to this side and replicate shore power, that it will then energize all of my shore power breakers and I'll be able to test them as well and everything will work. It was a very, very serious, stressful, and challenging week. I'm not going to lie. I thought that I had some serious issues with an inverter. I thought I had serious issues potentially with wiring in my box. All at the end of the day, the two things that I fought the most was problems with the MK-3 and problems with the device that I was using to test my circuits, because at this particular point in time my fridge has been running for the past 2 hours, and when I plugged it in and turned it on, it increased my amperage draw by about 5 amps maybe. And I just opened it up to demonstrate and I could feel the cold air and it is definitely working. So I think at this point I'm at a good spot. I am going to clean this all up. I am going to close it all out. I am going to call this a successful smoke test at this point, even though it started out with some major fails. And then we're going to move on. One of the biggest things that I need to do at this point is get my solar installed for 2 reasons. Number one, let me see if I can show you real quick. Yeah, if you can see the screen, the glare is unreal, but I'm sorry for that. There we go. So it is well after 8:30 at night. And as you can see, my compartment temp is at 88 and my battery temps are all sitting well above 80. When I came out here this afternoon after work, my compartment temp inside this area right here was almost 100 degrees. I've got to get solar on this bus. I've got to get this system stabilized, and I've got to be able to let it run so I can use my mini splits to keep it environmentally controlled. It is getting way too hot in here. At this particular point in time, my thermometer says that it is 79 degrees, but yet the temperature in here is nowhere near that, and these fans have been running for about 4 hours, if not longer. Got to get that taken care of. One of the things I do want to show you as well, as you can see, I'm running about 49% battery capacity based on my smart shunt. I'm running about 54% capacity based on my Redodo battery monitor. So I'm trying to run these down on purpose. I'm going to let them run down probably to about 10 or 15%. I continue to use them. I will tell you that the challenges that I had with trying to figure out the issues with my AC distribution and using that heat gun and it surging to 100 amps depleted those batteries quickly. So I think they'll slow down at this particular point in time. But as you can see right now, if I was to leave everything on that's on right now, I've got about 5 hours. Once I turn everything off, it'll jump back up to several days. But I just wanted to bring you up to speed. So the smoke test, in my estimation, for the AC distribution is done. At this point, I'm calling it a success. But the road leading up to this point was a total fail for a lot of reasons, as we've already discussed. So we're going to wrap it here. We're going to close this one out, and then we're going to move on to other things. So thank you for being here. Please like, please subscribe, please tell me what you want to see, what you don't want to see. Give me some comments, give me some feedback. I would appreciate some insight on some of the things that I'm running into. That will help me in the future, because remember, I do have another bus to build. So that's where we're at right now. Thank you very much, and we're going to call it a wrap. Have a great day.